Here I want to talk a little bit about subtraction. So if I had the problem 8 minus 3, I could visualize this problem by starting with 8 of an object and taking 3 away. So here I have 8 dots, and I could take these 3 away. And how many are left? You can just count. There are going to be 5 left. So you would say that there are 5. That 8 take away 3 is 5. Okay, so this is a takeaway approach. You could visualize this with a number line as well. You could go up to 8 on a number line and then just go back 3. So you go forward 8 and then back 3. 1, 2, 3. And then where do you end up? You would end up at 5. Let's talk about how we can approach problems like this in different bases. So if I wrote down 8 minus 3 in, like, I don't know, base 9 or something like that, 8 minus 3 base 9 would be the same problem as 8 minus 3 base 10, because these are just like a single digit, right? So it gets a little bit more interesting if we go up to the second digit. So if I write 1 0 base 6 minus 2 base 6, what would this be equal to? So we talked about this. This was a takeaway approach over here. You could think of this type of problem over here as a missing addend problem, which you could have done up here too, by the way. So let me talk about it up here before I go up to a different base. If I wanted to talk about 8 minus 3 equals 5 using a missing addend approach, you want to think about it as follows. So like 8 minus 3 is equal to question mark, right? So really this is the same as solving the problem 3 plus what is equal to 8. And so if you know what number you can add 3 to, or add 5 to, if you know what number you can add to 3 to get to 8, then that would answer the question of what is 8 minus 3. Right? And so if you knew, oh, if I just add 5 to 3, that would give me an 8, then that would answer the question for you. So let's translate that over here to a new base. So 1 0 base 6 minus 2 base 6, what is that equal to? So we're trying to solve the problem of 2 base 6 plus what is equal to 1 0 base 6. Okay, so if I wanted to think about this problem, knowing how to count in base 6 is pretty important, because a lot of times we'll be like sort of counting down when we're doing a subtraction approach, especially with like a takeaway method. If I wanted to count up to 1 0 base 6, it would go 1, 2, 3, 4, 5, and then once I get to what for us would be 6, we get one group of 6 and then 0 singletons left over. So I would write 1 0 base 6, right? So 2 plus what would give me 1 0 base 6? Well, 2 plus 4 would bring me up to 1 0 base 6. And so the answer would be 4 base 6. Okay. You could have, of course, approached this in a takeaway method as well, using, so if you represented 1 0 base 6, you would have to know that that looks like this. That's really 6 things to us. 1 0 base 6 is 6 things. And then if you take away 2, then you're left with 4. Let's do another one. This is like 1 2 base 8 minus 5 base 8. So with this, we could do a similar approach, or we could think of counting down in steps. So 1, 2 base 8 minus 5 base 8. So if I had 1, 0 base 8 minus something base 8, then we could approach it in the same way that we did the previous problem. So notice that 5, we can like think of this as like a 2 and a 3. Okay? And if I take 12 and I take away 2, then I end up at 10 base 8. Okay? So if I take away 2 first, and then I take away 3, then I have 10 base 8, and then I take 3 away from that, and then I could just sort of count backwards and get to 5. So 12 base 8 minus 5 base 8 is, if I take 2 away first, it's 10 base 8, and then minus 3 base 8. And if I have 10 base 8 things and take away 3, I'm going to be left with 5 base 8 things. Because, you know, to us, this is one group of 8 minus 3. 8 minus 3 is 5. You can think of it that. Try not to think of these things in base 10 until maybe you're trying to justify your answer to yourself. Try to think of these things like purely in whatever base we're in. Part of the reason that we're like really doing all this is because we're trying to understand the thought process that kids go through when they are learning this stuff for the first time in base 10. They don't have a base 10 reference to go off of with this stuff. They have to learn everything from scratch, and so when you're doing these problems, try to do everything from scratch without translating into base 10. But yeah, anyway, that's how you would do that.